Absolutely. Thank you very much. And thank you everyone for being here and for the opportunity. So good morning, good afternoon, or even good night. For some of you and even Alexander, it's really early. So thank you, my friend, for being here. So what we're trying to talk about in this presentation is really to show how the Eclipse Foundation and OpenHW Group, as open source focused organizations, are trying to build a comprehensive stack from the CPU cores all the way to the integrated development environments, really targeted at IoT use cases and obviously leveraging RISC-V technologies. So the starting point for this really is our, well, first, the structure of this presentation is really, we'll give you a bit of context about who we are as organizations, and then focus on what OpenHW Group is doing in software. And finally, I handle it to Alexander, who will focus really on the CORE-V IDE project that he is building at OpenHW. So really, the starting point for the discussion is the realization that you can only create a successful ecosystem by being completely open. And a fantastic example for that is bread. When you think about bread, we don't know exactly, it's been lost in the mist of history, but we don't know exactly when bread appeared, when humans started baking bread. But wherever you go in the world, even in very remote locations, you will always find a local type of bread that you can try. And what makes bread so fascinating is this diversity. And the fact that the basic secret of bread making has been an open secret for all of that time. The diversity that we have in bread today and the great value of the worldwide bread market comes from the fact that it's been open from the very beginning, right? And so we want to do the same thing to hardware and software. And this is why the OpenHW Group and Eclipse Foundation came together in order to make that happen in the IoT market. All right, so who is OpenHW if you're less familiar with the organization? Essentially, OpenHW Group is a non-for-profit registered in Canada with a goal of developing a fully verified set of open source cores and all the enabling ecosystem around it. So we're talking about IP for system of a chip, software tool chains like GCC and the like, and obviously, as we just saw, emulation platforms, verification platforms, test chips, and even development kits. And on the other end, there's the CORE-V family of cores. So that's a family of open source cores for use in high volume production system on a chip. So really, CORE-V is really the leading project that we've got at OpenHW, and OpenHW is a nonprofit. So the way OpenHW works is really, really well structured in the sense that there's a technical working group and a marketing working group with each their own responsibilities, and OpenHW has got some of its staff, and there's the board obviously overseeing things. But when you look at inside the various components of the technical working group, you will see there are people in a task group working specifically on the open source CPU cores. There's a verification task group, an hardware task group, and software task group. And really, in my case, as someone working for Eclipse, I interact mostly with the software task group, but there are lots of very dedicated people meeting week after week in order to drive innovation on various aspects of the stack. So looking at the membership for OpenHW, you see plenty of logos there that I suppose you will recognize. And the great thing about OpenHW is that it's not just industry members like what we see on this slide, but there's also a strong focus on research. So if you have academic partners that you are working with, then there's a good chance that they could find a place around the table as well. And obviously, there's a number of wider ecosystem partners involved, and obviously the RISC-V Foundation is certainly a leading player there. And thank you so much for being here. And at the same time, the Eclipse Foundation is there, and the rest of my segment of the presentation will be trying to explain what we are doing along OpenHW Group for this ride. But first, let's focus on the IP core technology that you find in the CORE-V family. And really at this point in time, there are three main families of cores. CVE2, which is 32-bit and two-stage, so really small cores implementing just a key set of features optimized for low power and low area. And then the CVE4 family, 32-bit, four-stage, having 32-bit FPUs, DSP operations, including loops, SIMD extensions, bit manipulations. And finally, the CVE6 family, 32-bit and 64-bit, six-stage, which is really a more fully featured core that can run Linux and other Unix-like operating systems. And really, it's got superior TLBs and branch prediction among the other things. So that's really a more fully featured chip. So looking at specifically what's happening at the level of the software task group, there's a team focused on compiler toolchains. So there's GNU GCC, LLVM, and some proprietary toolchains included there. But there are also many other things, processor and platform models, and we saw part of that in the previous presentation, integrated development environments, and there that's not just the classical Eclipse IDE, but really there's also platform IO available, a hardware abstraction layer, benchmarking, and specifically EMBench, and some demonstration applications as well. So the scope for the software task group is quite large. Then going to the Eclipse Foundation, maybe some of you are less familiar with what we do, and many people in the industry still associate us closely with the Eclipse IDE, but really we are much more than that. We call ourselves the community for open innovation and collaboration, and really we have three guiding principles. We are community driven. We do the code first. So not that we don't care about blueprints, but we prefer writing code and working on things that are production quality and commercial grade. And finally, we differentiate ourselves by being especially commercial friendly in the sense that the licensing models that we support are certainly very amenable to commercial adoption. So by the numbers, we have at this point in time over 400 projects, over 230 members, and everything that we do is done mostly with a staff of 35 that are really there to deliver services to the community. So I'm not owning any project or anything like that. It's really about being at the service of the 400 plus projects that we have in the open source world. And IoT and Edge is one of our four strategic pillars. We still do development tools. We are the home to cloud native Java, and we do automotive, but really the part that I focus on is really IoT and Edge. And we do many other things than those four things, but really IoT and Edge is a core concern for us. Automotive is a core concern for us. And this is why we work so closely with the OpenHW Group. Now, focusing a bit more on what we do in IoT. So essentially, we have a working group that's called Eclipse IoT. That's really a set of building blocks for commercial IoT solutions, and they go all the way from constrained devices or connected things to edge nodes and to cloud. And obviously, our interest in RISC-V technologies, generally speaking, and obviously in the CORE-V family, comes from this focus on connected devices and a bit on the edge and gateways if you think about the CVE6 family of cores as well. So to give you a taste of what kind of community we're talking about, that's about in Eclipse IoT 32 million lines of code, 47 distinct projects, and 47 member organizations. You see the logos there. I pass on that quickly just to highlight there the collaboration that we have with the Linux Foundation and Kate on the Zephyr OS. So we ensure that our building blocks work well with Zephyr and vice versa, and are happy to support the Zephyr project. Now, when we come back to the title of our presentation, okay, we say we are walking towards a comprehensive open source IoT RISC-V stack. And this diagram is really the key part to understand. OpenHW Group put its focus on processor cores and IP tool chains, and up to a point development environments is covering a large swath of this. But then by being around to provide additional development tools and our IoT building blocks in the Eclipse IoT working group, and as well the cloud and browser-based technologies that you can find in the Eclipse Cloud Development Tools working group, you put the two together, you literally have the most comprehensive open source RISC-V stack that you can find in the market. And this is really important because, coming back to my point about openness in the beginning, only truly open ecosystems are successful over time. Maybe you will find some temporary success with a more proprietary approach, but ultimately open source wins. Linux won, and now RISC-V is winning. At least that's my point of view. And certainly when you combine what Open Hardware is doing with what Eclipse has, you have a formidable combination. Now, to give you a taste of how this happens in a more concrete project, one of the non-core project that Open Hardware is working is a specific MCU with a board. And here on this diagram, you see how the pieces fit together. You've got the traditional desktop IDE, the Eclipse one, or platform IO as a base, the various tool chains, the debugger, and then on the other side, a target software stack that could include FreeRTOS or Zephyr or other real-time operating systems. But really the focus here is to have all of this, as open source, literally from the MCU, the core on the MCU, and all the way to the top, to the development tools. Now, handing it over to Alexander to cover what's happening around the CORE-V IDE specifically.
Thanks, Frédéric. Okay, I'm going to continue sharing. Then I will ask you to just switch the slide. Okay.
I will advance for you.
Okay, so my name is Alexander. I am more or less active committer in Eclipse. So sorry, it's a bit early for me. It's just 5 o'clock in Russia of the morning. I'm participating in a lot of projects during those years. So I started probably from the very beginning, 20 years ago with Eclipse. And I'm also leading the small Russian consulting company now, ArSysOp, and we are doing consulting in IDE and tools, Eclipse based. And in the open hardware context, I'm leading the IDE effort. Next slide, please. And I would like to discuss briefly what do we expect from IDE, because I'm doing IDE a lot of time. So first, we would like to have a configurability, because especially for embedded project, it's so important to tune your IDE precisely. Then we need extensibility. So we always have a lot of new MCUs and boards and facilities like Debugger, the changes in tool chains and whatever. So it's really needs to be extensible. Then it should be scalable. It's very important for modern system on chips, because it gets more and more, it needs more and more code to be compiled and indexed simultaneously. So you can have really big headers, for example, that are just generated from your hardware descriptions and so on. For sure, it should be usable, because this is what let you be productive finally. And yeah, it needs some agility, but please next slide, because that, yes, we just okay. So in CORE-V IDE, we started to prepare the IDE bits from the very, very early moment, because we believe that then you develop new hardware and new MCUs, a lot of things should be delivered simultaneously if it's possible. So we consider hardware, software, and tools to be delivered simultaneously, but we also learned a lesson that if you start to develop software and tools late in the cycle, then it may cause a lot of issues that, for example, your hardware, it doesn't provide some debug interfaces that are suitable for software and tools, or your software is not friendly for IDE, that we can see a lot of times during the history. Okay, so we started from at the same time, and we fortunately we don't need to start from scratch. We have a great foundation of open source components in Eclipse Ecosystem, and we choose to use some well-known stuff like Eclipse modeling framework that allows to model, to provide schemas of data, describe some things like toolchains and so on. We have Eclipse platform that is very extensible and dynamic and very mature. We have Eclipse CDT that provides a lot of generic features. I will talk a bit later about that. And Eclipse Embedded CDT, also well known, as a part that have a lot of that helps to work with focus on embedded scenarios. Next slide, please. So talking about Eclipse CDT, it's more than 15 years of history, and a lot of companies already built successful commercial and open source products using that functionality. For sure, it's not all of them are listed here. I need to mention, yes, the things from Emperos and from Ashlink. They support the RISC-V and a lot of others. Next slide, please. And talking about what Eclipse CDT is, if you are not familiar yet, it's not only some code highlighting. It gives a much more functionality, and to have it all, you need to configure your project, and the configuration may be a bit sophisticated stuff, but you really can tune precisely how your project is compiled, how it should be debugged, and so on and so forth. So tune all the headers. Next slide, please. Here, I just showing some screenshots from what you have. And if you tuned everything right, then you are switching from just colored editor to a full function IDE. Then you have code navigation and a lot of features that you expect from IDE. Next slide, please. So it will also allow you to have a rich debugger experience. We already have seen some screenshot from Emperos that is based on that functionality. So it has a lot of additional views. It has JDB integrated out of the box and have a good extensibility to integrate other kind of debuggers. You can browse memory and do a lot of stuff. Next slide, please. What is also important, it has an ability to integrate the terminals, and that enables to scenarios like debugging through SSH and a lot of others with integrating third-party tools that needs some interaction through in command line manner. Next slide, please. And then I would like to talk a bit about Eclipse Embedded CDT. It was started a long time ago also by Livio and Esco, who did a lot of things to make embedded development easier. So as you know, it's not so easy to configure the project, and Livio did a lot to support really impressive amount of configuration for different architectures, for different boards, and for different debuggers. So we also reuse a lot of work from Eclipse Embedded CDT for RISC-V and other functionality, and for debuggers as well. It is now under Eclipse umbrella, so it's. I also recommend to have a look on this project. Next slide, please. And another big ecosystem is Platform IO. They support embedded development for, yes, they just incredible amount of boards. And as I know, they have around 2 million of downloads currently. So if you never tried that before, I really recommend to have a look. They are mostly focused currently on the S-code experience, and we let's say inclusively support them inside our ecosystem as well, because it's we are not locked to Eclipse CDT. We greet any other implementations, both open source and commercial, to support the CORE-V stack. So they also have a support for RISC-V and CORE-V. They started to have their own project under OpenHW umbrella. And next slide, please. And we have a good partnership with them between companies, and we manage it with to integrate experience what they have for VS Code inside Eclipse. So this is also a separate open source project on the Platform IO, let's say, cap. So you can find it in GitHub and either join or whatever, or provide your issues and comments, maybe patches. Next slide, please. So, and then after you initiated the project inside Eclipse, you also can switch from having all the platform your luxury to work in the Eclipse perspectives and use debugger and so on and so forth. So it's also possible to combine the technology from Platform IO with Eclipse IDE experience. Next slide, please. And the future plans is to provide better integration for a lot of things we have around. We have more and more in our ecosystem. So there is a GCC toolchain provided by Ecosystem and LVM toolchain that Tails is working with other people. We also need to add sample applications. So it's I believe it's not so easy to start with some board or technology without having sample application, and this is where we encourage you to join this effort. We plan to have more project templates that is yes dependent on sample application, and since we greet both open source and commercial stuff, we plan to support marketplace for that activity to enable that experience. Next slide, please. And we have a technology inside the under umbrella of Eclipse Foundation how to introduce such kind of functionality. We have an open source framework to control licensing constraints. It's Eclipse Massage. I'm leading that project, so we can easily check on runtime the permission to use particular feature that's currently supported for simple stuff like just product launching or using some action from UI, but we are working to have this available also for some installable stuff like you can have a license check before installing toolchain or some feature inside the Eclipse IDE or Eclipse CDT or something like this. Next slide, please. And also talking about commercial stuff around, we are working with our partners to introduce experience about checking the safety case for application being developed. So, you know, if you're working with automotive stuff, you know that ISA 26262 is. So it requires to build the compliance safety plan. And since we have a lot of metadata available because IDE provides it for us. For example, we know what toolchain is used and how it's used because we have all that configuration available. So we can not only help to build stuff, but also we can help to control that it still use it in safe manner. So then toolchain is used. Again, it should be qualified for the safe usage. This is where you can contact our partners in Germany, validators. And then you need to provide, when you're providing the safe product, you need to ensure that you're still using it in safe manner. So the tool safety manual guides you how to do that, but you need to control it interactively or during your development. And this is where we can help with that. Next slide, please. Yes, so having all the information from the IDE with all the metadata, and having information what was qualified for the safe usage, we can help to just keep you in the safety area. So we can control the options and so on and so forth, and finally provide a safe tool usage report. Okay, next slide. And yes, the most part of what we presented today is available open source, and you're very welcome to participate. Every contribution is valuable for us. It could be a piece of documentation, it could be some suggestion, it could be a suggested patch, a pull request. So to participate that effort, you need to create an account at Eclipse.org. You need to sign Eclipse contributor agreement electronically. It's really easy. And then you need to not forget to specify a GitHub identifier on your Eclipse profile. And then you just need to go through any repository, either from OpenHW Group or Eclipse Foundation, fork it, and do whatever you would like to change things in this world to the better manner, and then create pull request. So next slide. And I think that's it from my side. Thank you, and I'm ready to answer your question with Frédéric.
Yeah, it seems there's a question about Passage. So does it support exporting to SPDX, SBOM? So what Kate covered in her presentation.
So it is, let's say, not about what source license you use. There is a lot of tool around that does that. It's about the runtime constraints. You know, all that enter license key to continue using the product and so on. If it's answer your questions. So probably your question was about functionality from a bit different area. So again, Eclipse Passage is focused to put a constraint, to define a constraint on runtime or using some particular feature for whatever reason, I don't know, age constraint, location constraint, whatever, commercial constraint, and then check it on runtime, and I will let you go further or block your execution. Any other questions?
I don't. Oh. So additional question from Kate. For the runtime constraints, can you export into SPDX so others can share the info?
Into SPDX. So technically we can, since we know all the constraints defined in the functionality, we technically can export to any format. It's not yet implemented and not yet specified how it should be done, but you are welcome to specify that in a request. So I think you can easily find the project Eclipse Passage and it has a GitHub repositories, it has issues, so please join that effort and submit what you need, and we will discuss that.
Okay, so if there's any other questions, go ahead and put them into the Q&A. And gentlemen, if you can go over to the Q&A and help answer anything you see coming in there, that would be wonderful.
We'll do just that. Thank you very much.
You're welcome. Thank you for presenting.
Of course.